Good morning. Okay. So, we talked yesterday or Tuesday, about reduced row echelon form and the kind of basic process to go through Gauss-Jordan elimination in order to solve systems of equations. We did a bunch of 2x2 examples, and so today we're just going to go through and we're going to do an equation that has 3 variables, x, y, z, and then we'll move on to one that also has more variables than that to show really where the usefulness of Gauss-Jordan elimination comes through. Okay. So our first step in solving this is just to turn this system into an augmented matrix. Okay. So we take this and we just look at our coefficients, right? 2, -3, 1, -4, 8, -4, 7, 7, 7. And then on the right side of this vertical bar, which kind of represents like the equal sign, we have 2, -4, and 28. Okay. So our first step is we want to get a 1 in this top left corner. And a couple different ways we can do that. Now, an interesting thing that we'll always want to look out for, especially as a first step, is there an entire row that is divisible by a certain number? Okay, and so when I look at this, first I say, hey, yeah, check it out. This bottom row is all divisible by 7. So I'm going to start off by doing 1/7 times row 3. Okay, so that'll turn into 1, 1, 1, 4. First 2 rows stay the same. Now I did that because, well, one, it just makes it simpler, smaller numbers, but also it now means I have a 1 here. And remember, one of our row operations is to just switch the places of rows. So now let's do that. Let's switch row 1 and row 3. So now the top row is 1, 1, 1, 4. Second row stays the same. Two, -3, 1, 2. Okay, oops, and then my vertical bar. Now that we have a 1 in our top left corner, our goal is to clear the stuff below it, so to get 0 here and 0 here. So what I'm going to do is I'm going to first worry about just the -4. I'll do the 2 in the next step. So I ask myself, what do I add to -4 to make 0? +4. Great. So let's do 4 times row 1 plus row 2. Row 1 will stay the same. Row 3 will stay the same. It's just row 2 that will be changing for this step. Okay, so we go through 4 times 1 is 4. 4 plus -4 is 0. 4 times 1 is 4. 4 plus 8 is 12. 4 times 1 is 4. 4 plus -4, 0. And 4, wait, I lost my spot. Oh, 4 times 4 is 16. 16 plus negative 4, 12. Okay. Great, so I have a 1 and a 0. Now I want to get a 0 here. So what do I add to 2 to get 0? Negative 2. So negative 2 times row 1 plus row 3. Row 1 stays the same. 1, 1, 1, 4. Row 2 stays the same. But row 3 will change. So for row 3, negative 2 times 1 is negative 2. Negative 2 plus 2 is 0. Negative 2 times 1 is negative 2. Negative 2 plus negative 3 is negative 5. Negative 2 times 1 is negative 2. Negative 2 plus 1, negative 1. Negative 2 times 4 is negative 8. Negative 8 plus 2, negative 6. Okay. Let me do a quick check just to make sure up to this point that my operations were good. I would again, like I said, I recommend doing double check, triple check, any kind of check. We also could have done, in step 1, we took row 3 and divided it by 7 to get 1. We also could have done row 2 divided by negative 4. That would have also created a 1 here. So potential option. Let's see, 1/7. Okay, that's good. Row 1 and row 3 switch. 4, 0. 4 times 1, say 12. 4, 0. 16 plus negative 4, 12. Okay. Negative 2, 0. Negative 2 plus negative 3, negative 5. Negative 2 plus 1, negative 1. Negative 8 plus 2, negative 6. Okay, yeah, I think this is good. Again, just doing a little check. I don't want to have to go back and redo this all over again. All right. So our first kind of big step is done in that we have 1, 0, 0 in our first column. So now my goal is to get the second column not to be 1, 0, 0, but to be 0, 1, 0. Well, actually just start with the diagonal. So the next step is to take this diagonal, right, 12, and make that a 1. Okay? Well, take a look at row 2. All these numbers, 0, 12, 0, 12, I can just divide by 12. So row 1 stays the same. Row 2, 0 divided by 12, 0. 12 divided by 12, 1. 0 divided by 12, 0. 12 divided by 12, 1. Awesome. Okay, so I have that 1 there just like I wanted. Now I want to clear what's below the 1. So I want that negative 5 to be a 0. So I ask myself, what do I add to negative 5 to make 0? Positive 5. So we'll do positive 5 times row 2 plus row 3. Row 1 stays the same. Row 2 stays the same. The only thing that's going to change is row 3. So 0 times 5 plus 0 is 0. 1 times 5 plus negative 5 is 0. 0 times 5 plus negative 1 is negative 1. 0 times 1, or sorry, 5 times 1 plus negative 6, negative 1. So we've gotten 1, 0, 1, 0, 0. All right, our next step is now to make the next diagonal just equal to 1. So take a look at this third row. I can just divide row 3 by -1, right? Or multiply by -1, whatever. So I'm just going to do negative times row 3. First rows stay as they are. So I have everything that I want so far. This is row echelon form because I have 1, 0, 0 in my first column. The second column has 1 in the diagonal, 0's below it. Third column has a 1 in the diagonal. Awesome. So this is what we call Gaussian elimination, just going this far. But now to do Gauss-Jordan, we want to get rid of the stuff that is above it as well. And so for this problem, we went left to right to get the 1s in the main diagonal and then clear the stuff below. But now to clear the above stuff, we're going to go right to left. So, for example, we're going to use this 1. This is already 0. That's awesome. That's helpful. So now I'm just going to worry about this becoming 0. So what do I add to 1 to make 0? -1. All right, so we'll do negative row 3 plus row 1. It is fun. That's why you're here, right? I don't know why else you'd be watching this. All right, these two rows stay the same. Only row 1 will change, so let's just go through it. 1 times -1 plus 4 is 3. 1 times -1 plus 1 is 0. 0 plus 1 is 1. 0 plus 1 is 1. Okay, so now we have our column fully fixed, that the 1 and then 0 is above it. So now we'll move over to this column. So I have a 1 here. I just want to get 0 above that. So what do we add to 1 to make 0? -1. So negative row 2 plus row 1. So -1 times 1 plus 3. Well, here, actually, let me write. These two rows aren't changing. Only row 1 is changing. Okay, so -1 times 1 is -1. -1 plus 3 is +2. 0 times negative plus 0, okay, 0. 1 times -1 plus 1, also 0. 0 times negative times 0 is 0. 0 plus 1 is 1. All right, so this is now in reduced row echelon form. And we've talked about how to read this like from the TI-84 calculator. We've done RREF. And so what this means is, right, so this is in my perfect form. Only 1s on the main diagonal, 0s everywhere else. And then 2, 1, 1 going down the right side. So x equals 2, y equals 1, z equals 1, or 2, 1, 1. Just took a full sheet of my scratch paper. Yeah. That's how this goes. And now, Matthew, imagine that you did that full sheet of work on your scratch paper, and then actually you looked back and realized that this was supposed to be a -4, but you accidentally put like a +4 here or something dumb like that. And all your work that you just did was completely useless. That happens a lot. A lot of errors of, you'd be surprised, of just people copying down the wrong number just from the beginning. Some of you will do it too. Okay, let's go ahead and do this one too. So we have a system of equations, but you might notice this system has 4 variables and 4 equations. Yikes. All right, but same thing still applies. So let's first just create the matrix. All right. So take a look here. Notice for example, like 2x plus 2z equals 8. You always have to consider what variable is missing. Right? So we made a decision based on how our decisions, like this is my w column, this is my x column, this is my y column, and this is my z column. So since this equation does not have a w in it, that's why there's a 0 here. Or since this equation does not have a y in it, that's why there's a 0 here in the y column. Okay, so you'll have to consider that whenever you're creating your augmented matrix. Make sure that there's a placeholder of 0 even if that variable doesn't show up in the equation. Okay. All right, so this sucks, but it's there's some prep work here that's already done for me, which will help. So again, it's w, x, y, z. Notice that this is already partly done. Look, I already have a 1 here, which is what I would first want. And then my next step after this would be to get zeros all below it. So I almost have that. I just have to worry about this 3. Okay, so even though this is a larger matrix to use, I'm at least set up in a good spot that I already have a 1 here and then a 0 and a 0. So that's promising. Okay, so first matrix operation. I'm thinking, what do I add to 3 to make 0? -3. So -3 times row 1 plus row 4. Right, so these first 3 rows will stay the same. Okay, but row 4 will change, so I'll go through and do the math. -3 times 1 is -3. -3 plus 3 is 0. Times -1, so -3 times -1 is +3. +3 plus -3, oh, also 0. That's helpful. -1 times -3 is +3. +3 plus -2 is 1. 1 times -3 is -3. -3 plus 4 is 1. 0 times negative 3 is 0. 0 plus 7 is 7. All right, so luckily we didn't have to do 1,000 steps to get there. Now, sometimes we might, maybe there's not already a 0 here and here, so we'd have to worry about those two. But for this problem, we only had to worry about that 3. So now let's move over and say, okay, now I want this to be a 1. Well, again, when you're looking just to create a 1, an interesting thing that you can sometimes look for is dividing an entire row. So look at this row. All these numbers are divisible by 2. So let's take row 2 times 1/2, or divided by 2. So row 1 stays the same. Row 2 gets divided. 2 divided by 2, 1. 2 divided by 2, 1. 8 divided by 2 is 4. Row 3 stays the same. Row 4 stays the same. And another lucky thing happens. We already have zeros below it. We don't even have to worry about making those 0. It just turns out they were already 0 based on the numbers from this problem. So that's super helpful. Okay, so now we move to our next diagonal that we want to make 1. So right now it's negative 1s. That's easy to make 1 because all we need to do then is take that row and multiply it by negative. Okay, so I'm excited. So negative row 3. All right, row 1 stays the same. Row 2 stays the same. Row 3, everything changes sign. So positive 1, positive 2, positive 8. And row 4 stays the same. All right, now I want this to be 0. Right, below this 1, I want it to be 0. So what do I add to 1 to make 0? Negative 1. So negative row 3 plus row 4. A lot of this is just copying down the same numbers that we keep copying down. Row 1 and 2 don't change. Row 3 doesn't change. So negative 0 plus 0 is 0. Negative 0 plus 0 is 0. Negative 1 plus 1, 0. Negative 2 plus 1, negative 1. Negative 16, or wait, sorry, no. Negative 8, right? Negative times row 3. So 8 times negative is negative. So negative 8 plus 7, negative 1. So we got the 1 and the 0. We got 1, 0, 0. We got 1, 0, 0, 0, 0. All right, our columns are looking good. So last thing is now just to take this negative 1 and make it positive 1. So let's do the same thing we did over here. Let's just multiply row 4 by a negative, and that'll help fix that. So negative row 4. Okay, so now we're perfectly in reduced row echelon form. All right, 1, 1, 0, 1, 0, 0, 1, 0, 0, 0. All right, so we can see that main diagonal has just all ones. Everything below that is a 0. Okay, so now we just start clearing things that are above it. So now we're going to move right to left. And now I'm going to start with this green. Oops. I'm going to start with this green 1 here and use it to clear everything that is above it. So I want this to be 0, this to be 0, this to be 0. So let's just start with the 2. What do I add to 2 to make 0? Negative 2. All right, so negative 2 row, oops, not row 2. Negative 2 times row 4 plus row 3. Okay, row 4 will stay the same, so I'll go ahead and write that one. But row 3 will change. So 1 times negative 2 is negative 2, and negative 2 plus 8 is 6. 1 times negative 2 is negative 2. Negative 2 plus 2 is 0. The rest of this stuff, look, the rest of row 4 is just zeros. So when I add zeros to any of these, so 0, 0, 1. Okay, just going to realign this a little better. Okay, now let's worry about this 1. What do I add to 1 to make 0? Negative 1. So negative row 4 plus row 2. Row 1 stays the same. Row 4 stays the same. Row 3 stays the same. All right, it's just row 2 that's going to be changing. Negative 1 times 1 is negative 1. Negative 1 plus 4 is 3. Negative 1 plus 1 would be 0. And then 0 times negative 1 plus 0, 0 times 0, right? Okay, so these are just going to stay the same. 0, 1, 0. All right, we're almost there. We're getting there. So I have a 1, 0, 0. Now I just need to worry about this last 1. What do I add to 1 to make 0? Negative. So again, negative row 4, but now plus row 1. Two, 3, and 4 will stay the same. Row 1 is the only thing that's changing. So 1 times negative 1 is negative 1. Negative 1 plus 0 be negative 1. 1 times negative 1 is negative 1. Negative 1 plus 1 is 0. 0 plus negative 1, 0 plus negative 1, 0 plus 1. So these will all just negative 1, negative 1, 1. Okay, so we did it with our first column. Now moving right to left so that I can get the above stuff. So now I move over to the next column, and I want the zeros to be above this one as well. Now I already have one of the zeros, so let's just focus on this one. What do I add to negative 1 to make 0? Well, just positive 1. So I don't even need to do any type of crazy multiplication. Let's just do row 3 plus row 1. I know this is painful, trust me. Row 1 is the thing that will change, so row 4 is staying the same. Row 3 is staying the same. Row 2 is staying the same. It's only row 1 that's changing. So 1 plus 3 is 4. Or wait, hold on. Not 1 plus 3, my bad. Row 3 plus row 1. So row 3 is 6. 6 plus negative 1 is 5. Zero plus 0 is 0. 1 plus negative 1 is 0. 0 plus negative 1 is negative 1. 0 plus 1 is 1. Okay. So we got 1 zeros above. We have 1 zeros above. So lastly, we have a 1 right here. Let's just make this a 0, and then we'll be done. Row 4 stays the same. Row 3 stays the same. Row 2 stays the same. Oh, oops, I forgot to write what we were doing. So what do I add to negative 1 to make 0? Just positive 1. So I'm just doing row 2 plus row 1. So row 2 plus row 1, so 3 plus 5 is 8. 0 plus 0 is 0. 0 plus 0 is 0. 1 plus negative 1 is 0. 0 plus 1 is 1. We did it. So W equals 8, X equals 3, Y equals 6, Z equals 1. Eight, 3, 6, 1. I think for the AFA, let me check. Not quite. Not quite. We need one more day. We need tomorrow, and then you'd be ready to take the PFA. So close. That fifth objective is the last thing we need for the PFA. All right. Well, that's all I got. It's just a lot of repetition of steps. It's annoying. I know that. It's a lot of crap. It's a lot of space. But it is good for solving systems of equations of any size. Here we had 4 variables. We could do it with 5 variables, 6 variables, 7 variables. I put an example here just to show. This is a 6 variable system. We could do it with this. We're not going to. Don't worry. But we know the steps to do it. 1, 0's below it. Great. Move to the next diagonal. 1, 0's below it. Next diagonal. 1, 0's below it, etc. Once you have all that, then you worry about zeros, getting zeros above, getting zeros above, getting zeros above. Super fun. So you can just do this, but again, we're not going to do this problem. You can just do this problem on the weekend when you have some spare time because you're just bored, you want to do something fun, exciting. Hop back to this, do this problem. You'll be good to go. But all right. Yeah, tomorrow we'll come back. We'll talk about some things called determinants and an inverse matrix, and which are not that bad. Very, very small calculations for those, so it's not like this at all. It'll be much better. Oh, at least 3 sheets of paper for sure, 100%. Probably at least 4, I would say. Because there's not zeros. There's not a lot of zeros in here, if you see. Every equation has every variable. Just think, this last question that we did, this was made pretty easy for us because these 2 equations don't even have 2 of the variables. So we started off with a 0, zeros here, and a 0 here. That was super helpful. That would have added lots of more steps. So yeah, that would be a monster. Good luck. I know you'll all attack that. Okay. But otherwise, I'll see you guys back here tomorrow. We'll work on that 5th objective, and you'll be good to go.